Hey everyone, welcome back to the channel. In today's video, we will learn about Kirchhoff current law, commonly called as KCL. It is one of the most fundamental laws in electrical circuit theory. Let's get started. Kirchhoff current law states that the algebraic sum of currents entering a junction is equal to the sum of current leaving the junction. If you look at the small example here, where you have a junction with several branches, in some branches the currents are coming towards the junction like I5, I1 and I3, whereas the I2 and I4 is going out from the junction. In case if we consider the current coming towards the junction as positive, then we can write this as plus I5 plus I1 plus I3. On the other hand, the current going out from the junction we consider as negative, then we write as minus I2 and minus I4. According to the KCL, we can write this as plus I1 minus I2 plus I3 minus I4 plus I5 should be equal to 0. If you rearrange this equation, you will get I1 plus I3 plus I5 equals I2 plus I4. From this equation, you can say the current comes in I1, I3 and I5 must be equal to the current going out, which is I2 and I4. In simple words, you can say the total current coming into a junction equals to the total current going out. Now we will move into a question. In this circuit, our aim is to find I2, I5 and I4, where I1, I3 and I6 values are given. I am going to consider this junction as A, this junction as B, this junction as C. So at the junction A, I am going to apply KCL. So KCL states that the current coming in equals to current going out. At the junction A, I can write it as I1 equals to I2 plus I3, where your I1 current is coming towards the junction, but I3 and I2 are going out of the junction. According to this equation, you can find I2, it's I1 minus I3, where you can say I1 is 3 amperes minus I3 is 1 ampere, so that I2 is 2 amperes. Second, at the junction B, I am going to apply the KCL, where your I2 and I4 are coming in towards the junction. So I can write I2 plus I4 must be equal to I6, where your I6 is going out from the junction. From this equation, I can say I4 must be I6 minus I2, where I6 is 1 ampere minus I2 is, from this equation, 2 amperes, which is minus 1 amperes, which means this minus represents your arrow should be in this direction. So actually the current flows from P to C. Now let's try to find out the I5. At the junction C, if I apply the KCL, the equation represents like this: I3 should be equal to I4 plus I5, where at the junction I3 is your current coming in and I4 and I5 is going out from the branch. Then I5 should be I3 minus I4. I3 that we already know, which is 1 ampere, minus I4 also we previously found out, which is minus 1 ampere. So it will be 2 amperes. Now let's try to apply the KCL for a network. If you consider a network instead of a junction, according to the KCL, we can also say that in a network, the current coming into the network should be equal to current going out from the network. According to this example, we can write I1 plus I4 plus I5 should be equal to I2, because the I1, I4 and I5 are coming toward the network, but only I2 is going out from the network. Now let's try to prove this rule. Here I am going to consider two junctions A and B. If I apply KCL at junction A, I can write as I1 plus I4, which are the current coming into the junction, it should be equal to I3, where is going out from the junction. This is the first equation. At B, junction B, I can say the I3 and I5 are coming towards the junction. So I3 plus I5 coming toward the junction, that is equal to I2, which is going out from the junction. This is number 2. In the second equation, instead of I3, if you replace it I1 and I4, we can write this equation as I1 plus I4 plus I5 should be equal to I2, where this is the initial equation that I have derived. In here, I1, I4 and I5 are your current that coming towards the network, whereas I2 is the current going away from the junction. So at a junction or a network, we can say that the current coming in should be equal to current going out. Now we will do a question on this. In this question, our aim is to find I3, where I1 is given as 2.5 amperes, I2 is given as minus 1.5 amperes. If you consider this as your network, according to the KCL, we say the current going toward the network is equal to current going out from the network. According to that, we can write I1 plus I2 plus I3, which are the currents going towards the network, should be equal to current going out from the network. Since we don't have any current going out from the network, we can write it as 0. According to this equation, I3 will be minus I1 minus I2, minus instead of I1 2.5, minus instead of I2 minus 1.5. That will be equal to minus 1 ampere. This minus represent actually the current going from here to here. So that's all about Kirchhoff current law, a simple rule that ensures current is always conserved in a circuit. If you found this helpful, share it with your friends. In the next video, we will discuss about Kirchhoff voltage law. See you there.